So today I'd like to look at a couple of examples, some case studies in our ER diagramming as we study this a little more this week in more detail. And the idea this week is to have you get a little more practice in ER diagramming. So let's take a look at a couple case studies. So our first case here, this is actually case 2, and I will give you the links a little bit later on. In Blackboard you'll find these. So we have a little description, emerging entertainment, sorry. We'd like to unseat Netflix. We have some business rules. So we talked last time about business rules. So the business rule defines exactly what we're going to do as far as entities. Now, bear in mind, with these diagrams, I did not put a lot of information as far as attributes for these entities and so on. So you have to keep that in mind. So here, let's look at these. We have a movie has one production company. A production company produces many movies. So production company's down here. And movie. So movie is produced by one production company, and this is a mandatory one, so one and one only. So we'll call that a mandatory one. And a production company produces one or more movies, many movies. So we would assume one. Now the important thing about this is really to write down any assumptions you make. So if you say, oh, well, essentially, movie, a production company produces no movies, potentially, then tell me that as an assumption, but because many is a little vague. Second business rule is a movie has one or more genres. A genre has one out of many movies. So here's a genre, and a movie has one or more, so mandatory many. And a genre is part of, has one, none, or many movies. So here's an optional many we have here, okay? And then a movie has one or more actors. An actor stars in one or more movies. So actor has one or more movies, and again, actor stars in one or more movies. So that's a mandatory many on both sides. So here we illustrate a few things. We had a one-to-many here. We have a many-to-many here with an optional many, and another many-to-many. Now let's take a look at something a little more complicated. This is case 1. And this is for a university. And again, we'll go through a few of these. There's like 7 of them I solved, so we may not go through all of these, but I just want to give you a little feel for exactly how to look at some of these. So here, let's look at the business rule. So many students apply for admission to one department. One department has many students apply for admission. So when you think about this, you have to start thinking carefully. So if I said, well, let's just make it a many-to-many. First off, that means I could never apply to that department again. And that's really not true, because when you think about it, when you're in university, you're going to apply. You might apply more than one time, right? Particularly some professional schools like medical and law school. So if we just had something like this with a many-to-many, then what we would find is that we're going to end up having issues because we can't apply a second time. So what I might think about instead is saying, well, let's make this a, there we go. So I'm going to make it a many-to-many. I couldn't find my arrowheads for a minute there. I think they changed things on me. So I could, put a disposition here and a date, but once I've done this one time, I can't apply again. Because what's going to happen is I'm going to have a table down here. That table is going to have the student ID, department ID as the primary key, okay, the identifying attributes. So we couldn't have more than one of those applications. But let's remove this. If instead what I do is I say, oh, well, here I have the student in the department. I have what we call, this is a little text down there. There we go. This is what we call an associative entity. Okay, so that means that it's actually an entity. Oh, so I spell that right, entity and relationship together. Okay, so it does both. So we call it associative. Also, what that has down here, let's put a little bit of text over here again. I'll draw an arrow down here. We call a surrogate primary key. So what does that mean? Well, that means that this uniquely identifies every row of applications. So application is going to still have the student ID, department ID, but it's going to uniquely identify this. So I could apply twice in the same year if I wanted to. It doesn't matter. So I'm going to end up with information about the applicant, but it's unique. Okay, so that's what we call an associative entity. That's a special case. I'm going to delete our little comments here. Goes out of our way. Okay, now, next thing is one department is part of a college, and a college has many departments. So a department belongs to one college, only one, and the college has one or more departments. One student is assigned to one admissions counselor, so we have here, and the admission counselor has many students assigned to him or her, right here. And then finally, they're accepted or denied, so that's a disposition of that, so that's kind of part of this. But then they could be conditionally accepted to another major, another department. A department can conditionally accept one, none or many students. So again, they conditionally accepted one, none or many students. They're accepted into one department conditionally. Now, we don't really cover date here. We'd have to get into a many to many to do that, but this works okay doing it this way. Okay, so that's an associative entity. Let's see what we have for case 3. All right, so here we have Jim's Diner. And Jim's Diner serves food, obviously. So one food item is supplied by many vendors. So food item, vendor, supplies, many food items by many vendors. One supply item supplied by many supply vendors. They supply many items. And then we have one food item is part of many menu items, and one menu item is part of has many food items. Okay, so at least one, but many. And a customer orders one or more menu items. They could order none, I guess. A menu item is ordered by one, none, or many customers. We have that. So we could have a menu item that's never ordered, something really lousy. The problem we have here, which kind of illustrates our associative entity a little better, is simply the fact that we have item ID, customer ID. So item I1, customer C1, item I2, customer C2. We get into trouble right here because suddenly I1, C1 can't have that. So that's impossible to have in the situation. So how do I fix that? Well, I can simply fix this by adding the associative entity. So now I have an order ID, and a date, and a quantity. So here you see that on a certain date, I didn't put the dates in, but order ID 3 is the same as order ID 1 as far as customers. But maybe this is 1/1/20, and this is 1/3/20, for example. So that fixes that problem. Okay, let's look at one more at least. Okay, so this one a little bit more complicated. This is the ride share company. And so he says a ride has one origin and one destination, as well as one vehicle. Okay, so a ride has an origin and a destination. Here we have a situation where we have a relationship that's going to be two relationships between two entities. So ride has one destination, has one location, has one destination. Ride has one origin. Location could be a destination for one, none, or many. Rides, same thing with origin. Okay. So a customer can book many rides, or I can book by many customers. So customer So instead of doing, if we did book, we have the same issue we had in case 3. We have booking instead with a booking ID and a cost and a tip. Keep track of the tips that they mention up here in the narrative and the cost. Also, we have a three-way. So this is what we call a ternary relationship. So this is a three-way between vehicle, ride, and customer. So there'll be the vehicle ID, the customer ID, and the ride ID all inside of here as foreign keys. So now I could look up for any booking, what vehicle it was in, who the customer was, the ride, which, and I've done it this way so you have fixed rides, right? That's always going to be dynamic and changing, but we just keep a database of rides. All right, so let's see. When a customer books the ride, the price of the ride and tip for that customer recorded, right? So the cost, the price could actually change, right? On demand. Each vehicle maintains a daily log of non-rideshare miles as well as gas purchase. So vehicle logs many non-rideshare miles. That's for one vehicle, so that's going to be the date and the miles driven. And then purchase, when they purchase gas, right? The date, the gallons, the cost. So we keep track of that for the vehicle. Okay. This was a little bit easier, probably the last one we'll do. So products are supplied by one or more suppliers. A supplier supplies one or more supplies. So again, product, one or more suppliers. Supplier supplies one or more products. Product is purchased. We keep a purchase instead of the same issue again for the associative entity with the surrogate key. We have purchase ID. We have the date and the quantity and price. Customer ID and product ID here. Okay, so that works out okay. So customers purchase one or more products, purchased by one, none of many customers. So again, we have that. Purchases include the price and sales tax charge. Okay, so price, I didn't put sales tax in here. Okay, so that finishes up our little discussion of those case studies. The next video we'll look at is going to take a look at the homework assignment 1.1 and review that. Okay, so we can go over that as well.